All right, thank you for listening in. This is Statistics from Aguirre, Lesson 4. So today we're going to talk about is wisdom in how to use correlation and regression in scatter plots. So in the previous lesson we talked about how you actually do them, and today we're going to talk about how do you deal with outliers, how do you deal with curved relationships that are not linear, and how do you actually interpret your results, which is probably the most important. So the first thing that we're going to talk about is how do you deal with outliers. So imagine that you have some plot here. Imagine that your data look like this. So you measured a bunch of things here, and then there's one, we'll say, that's down here. Right? So that should be the same size. We'll make that same dot as all the other ones. This one, we call this one an outlier. Why do we call it an outlier? Because it sits by itself all the way on the x-axis, right? There's no other points near it. It might be closer on the, it's not too far away from on the y-axis, but it certainly is far away on the x-axis. And remember that regression and correlations are very sensitive to outlying points. And so if you draw a regression line through this, it might look like, I'll draw it in blue, it'll look like this. And in fact, the line would extend all the way up and all the way down. So, right to the intercepts of both these axes, somewhere around there. So, how do you first identify whether a point is an outlier? First you just look at it and say, oh, there's an outlying point. What you want to be worried about is if it's a problem or not. So, it's a problem is if you remove the point from your data. So if you have, you have a table here of, I don't know how many points there, say 30 points, and this one point is out here. If you just remove that one point from your data, and now you do another regression line, and maybe your regression line actually looks like something very different, right? If you look at all these points, do these points look like they have a relationship that's curved downwards? Not really. These ones maybe slightly. I'd say if I were to draw a line through these, is that it would probably look maybe something like this. Right? That's a very different line from that line. Right? So if you have some outlier here, first, if you think you have an outlier, the first thing that you want to do to identify whether it is, if it's problematic, is to just remove it from your data and then do the regression over again and see if you get a different line. And if you do get a very different line, like in this situation, then you got a problem. So if the line is actually the same, so let's say that you actually did this regression line, and in fact you did a second regression line, and the second regression line ended up being maybe like this, that's very similar to that. You can probably leave that outlier in because it doesn't really influence your results particularly much, right? Because these two regression lines are very similar. But if it does change the regression line a lot, then you want to decide how to do with it, what to do with it. And essentially you have two broad options in how you can deal with outlying points. So one is, and the best option, is to try to find more points like this one. Right? So let's remove this, let's graph this again, and let's remove these regression lines, and we'll see what that would actually look like. So what I'm saying is if you have a bunch of points here, and then you have a point here, and you think that this one might be a problem, the best thing that you can do is to try to find other points like it, right? So maybe you actually find out, oh, okay, I can get more points over here, and now what you can do is you can either continue to draw. Now you can either do another regression line between here and here, or what you can do is actually you can treat these as categorical bytes. So you can treat this. So if you're looking at, let's say that this is, we will say, let's say no, it wouldn't be precipitation. Let's say temperature and, well, let's say percent time sleeping. Or though, let's say percent time moving. So let's say that you're looking at lizards, let's say, or lizard, a bad example. Let's go with ibex. Let's say you're looking at ibex, and you measure temperature, and you have a bunch of days when it's cold and a bunch of days when it's hot. And what you say and what you find is that on days when it's cold, you find that ibex spend a lot more time moving, right? And then when it's hot days, they spend a lot less time moving. Now, if you can get points like this, instead of necessarily trying to draw a line between all these points, maybe what actually makes more sense is if you just treat these as a categorical variable. So instead of having temperature on a linear scale, we just say, well, I'm just going to clump these together and say these are cold days and these are hot days. And then I can compare the percent time that ibex spend moving when it's hot versus when it's cold. And I'll just take the average of all these points and the average of all these points, and I can compare them rather than doing a regression. So that's one option, right, is to get more points like it. But let's say oftentimes you can't, right? So let's say that you're looking at this relationship and, it takes a really long time to get another cold, like these very hot days, let's say, are very rare, and so it takes you a long time. So this happens, for example, if you're looking at relationships between precipitation and, say, plant growth, right? If you get some very, very wet year that only happens every 10 years, so for you to get another point like an outlying point would take you another 10 years, right, just to get 2 points. And now your data would look like this after 10 years, right? It might look like this, and that's not a whole lot better than what it was before. And if you wait another 10 years, now you've waited 30 years, right? Now you wait 30 years and your data look like that. That's better, but it's still not great, right? So there are a lot of times where these outlying points are really rare, they're really hard to get, you can't get more. So what do you do if you have a point, if you can't get more of them, you just can't do it? Then you have two options. So, then what you really have is you need to think about whether this point out here is representative of the same relationship that all these points are here, rather than out here, right? So let's think, for example, let's change this graph, and let's say that we were looking at, we were looking at vultures, and we're capturing vultures, and we were looking at, let's say, and I don't know anything about blood physiology, but let's say that we're looking at blood physiology, blood chemistry in vultures, and here we have carbon dioxide in the blood, so is that percent carbon dioxide? Let's pretend that that's how you measure carbon dioxide in vulture blood, right? And here you say that this is, what are we going to put on the x-axis here, or the y-axis rather? Let's say that we're going to put, O2. Sure, why not? We're going to put oxygen in there. That'll probably have a negative relationship. Right, so maybe you say that, in general, sort of, if you look at this, you might say, the more carbon dioxide you have in the blood, the less oxygen you have in your blood. And let's be percent oxygen in your blood. But, if you look at just these points, without this, that looks like no relationship at all. Right, so maybe you had some bird over here that you measured all these birds in the nest, but this bird escaped from the nest and flew 2 kilometers away, right? And so all these birds are resting, and then you have one bird that flew 2 kilometers away. That bird that flew 2 kilometers away is probably not representative of the same things that are happening in birds that are resting. And so then you can just say, well, you know what? A point is gone. I'm just going to delete it and pretend it's not there. So if you do that, you have to be careful, because if you remove this, is very close, or this can be very close to data manipulation, right? Where you're intentionally changing your data to make it fit some pattern, right? That's not to say that you don't have a good reason to do it, but you need to report what it is. So if you've done this, then you need to say, I removed one vulture because it flew away from the nest, and we don't think that it was representative of the same processes that were happening within these points. So that's That's one way to deal with that, is just to delete it, explain why, and if you think it's different.